Hello, the purpose of this video is to move from algebra tiles to area model when we are expanding binomials. So we're going to use what we learned when we operated with the algebra tiles, but this time we're going to move away from the tiles and use the same concept with our area model. So we're going to expand these expressions that we see here. Let's begin with x plus 5, x plus 6 multiplied by x plus 5. So we're going to set it up just like we did before, except that this time I'm not going to use tiles. I'm just going to write the expressions here. X plus 6, maybe the length, and here x, I'm going to carry the sign with it, plus 5. So I hope you can see here that created a rectangle just like we did before with the tiles. And this rectangle is our area model. And so we are going to do the same logic with it, except now we can abstract to the variables we have. So when I multiply x by x, I have x squared. And then I'm going to do the same as before, go row by row. X times 6 plus 6 is going to be plus 6x. And then here I have 5 times x. So this is going to be positive 5x. And then finally, positive 5 times positive 6 is going to be positive 30. And that is my expansion. So if I want to write this, summarize, I have to remember this. Take a look. We talked about this before. We talked about these diagonal having like terms. So I would begin by putting my x squared. So the expansion will be the following. X squared. And then I have here 6x plus 5x, which is 11x plus 30. And that's it. So this is an alternative to FOIL that allows you to keep track of everything here and also allows you to see that when we're multiplying numbers, we can think of it as an area, the product of two numbers, length times width. I hope this example was clear. So that's the first example. We're going to move on and we're going to do the rest of the examples. So we have done this one. Now we're going to move to the next one, which is 2x plus 5 multiplied by x minus 1. Same methodology. We are going to take and write our two expressions. The length. And notice that I'm carrying the sign with the expressions that I write, okay? So I have 2x plus 5. I'm going to put this line on this side of the sign, multiply by x minus 1. And just like before, I carry on my multiplications row by row. So I go x times 2x is going to be 2x squared. Then x times 5 is going to be plus 5x. And the next row, negative 1 times 2x is going to be negative 2x. And negative 1 times positive 5 is going to be negative 5. And I have there my expansion. So you can see I have 2x squared, always the square term top left, the independent bottom right, negative 5, and the like terms that are on the diagonal, on these diagonal, that is so useful. So now I'm going to write the expression that is the expansion of this product. I'm going to begin with 2x squared. And again, sorry for the quality of the numbers. 2x squared, and then I group the diagonal, which is 5x minus 2x is going to be plus 3x, and finally minus 5. And that is the expansion. I hope you're beginning to see how friendly this method is and how easy it is to keep track of everything that happens. Area model. Good. That was example number 2. So now we are going to carry on and do the other 3 examples we have. Here we go. I'm gonna move these ones that we already did aside. And now let's move on to this one that has two negative numbers, x minus 3 multiplied by x minus 7. So please follow along. I hope you could see what happened. So we did what we've done before, x times x, x squared, and then x times negative 3, negative 3x. And then the next row, negative 7 times x, negative 7x, negative 7 times negative 3, positive 21. And just like before, I'm going to mark my diagonal, and then I'm going to write the expression simplified. So I have x squared, and then negative 7x minus 3x is negative 10x, and finally plus 21. Friendly, good. Doesn't matter what the numbers we throw at it, the model works, and it works very efficiently. So two more examples, and I hope that this is being helpful. So the next example is going to be this one, x minus 4 times x plus 1. Just now we're going to be doing it just a bit faster. So just come along, and hopefully these will make sense to you. Okay, so there it is. There's your model. And like before, diagonal shows us like terms is negative 4x and positive x. And then I can write the expansion just like this. X squared, and then negative 4x plus 1x is negative 3x minus 4. And that's it. Great. Last example, and by now I hope all this is becoming very easy for you to see. If you think you can do these without looking at the example, or you can stop the video now, that is perfectly fine. So let's do this one, last one. This one is, all of the examples have something different. So we started from something simple, some positive, some negative, some negative, some positive, some, both negatives. Now we have coefficients that are not 1. So we have 2x on one side and then 5x on the other, but the logic is the same. So let's do this product. So I'm going to do the same thing like before, 2x minus 1. And set up just like before. And the product doesn't matter what it is, it's the same. Now here I have 5x times 2x. Well, that's going to be 10x squared. Always the square term top left. And then negative 5x times negative 1 is going to be negative 5x. And 3 times 2x is going to be 6x. And finally, 3 times negative 1 is going to be negative 3. And there it is, our expansion. Just like before, our like terms are on the diagonal here. And I can see that when I group them, I'm going to get 6x minus 5x, which is just x, or 1x. So then my expansion would eventually look like this. 10x squared plus 1x, or just x, minus 3. This is a 10. Let's make sure that it is clear, is not 16. All right. And that it is. That's it. So this is what we've been doing. And basically, when we look at quadratics, we are doing this to go from factor form. All of these expressions are in factor form to expanded form or standard form. I hope you found this useful. Thanks for joining.